Hi, hello dear students, welcome to our channel Maths with PHANEENDRA. In this video, we are going to discuss exercise 9b. We are in the probability in the second section, question number 9. So let us have a discussion this question. The probabilities of three events A, B, C are such that P of A equal to 0.3, P of B equal to 0.4, P of C equal to 0.8, P of A intersection B equal to 0.08, P of A intersection C equal to 0.28, P of A intersection B intersection C equal to 0.09, and P of A union B union C is greater than or equal to 0.75. Show that the probability of B intersection C lies in the interval closed interval of 0.23 comma 0.48. So this result we are going to apply. So P of A union B union C, by using addition theorem on probability for three events, this can be written as P of A plus P of B minus plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. We can write it by using addition theorem on probability for three events. After that, we will simplify to get the interval of this P of B intersection C. So before that, the probabilities of three events are given now. P of A, P of B, P of C, and their intersection probabilities also given. We know that any probability is always less than or equal to 1. So we have, this is the standard result. In this sample space, three events are there. Clearly, we have the probabilities of three events A, B, C or P of A, P of B, P of C is given. And we have P of A union B union C. This is the certain event. That means A union B union C is equal to sample space. Now, this probability of all the events is always less than or equal to 1. This is the result, given result, the general result. And one more information is given, this value, and given P of A union B union C is greater than or equal to 0.75. So x is greater than or equal to some value means suppose x is greater than or equal to 3. So 3 is less than or equal to x, we will write now. So that implies that 0.75 is less than or equal to P of A union B union C. We will write it. From 1 and 2, we conclude that 0.75 is less than or equal to P of A union B union C is less than or equal to 1. Now, P of A union B union C, the addition theorem on probability for three events, you have to write it. So, first 0.75 less than or equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A or A intersection C plus P of A intersection B intersection C is less than or equal to 1. So here all the values we have except P of B intersection C. So P of A value 0.3. So 0.75 is less than or equal to 0.3, 0.4, P of C value 0.8 minus P of A intersection B 0.08 minus P of B intersection C, this is the required value, minus P of A intersection C 0.28 plus P of A intersection B intersection C 0.09 less than or equal to 1. So 0.75 less than or equal to. So we will add it 0.3, 0.4, 0.7, 0.7 into 0.8, 1.5 minus 0.08, 0.09, 0.17 minus 0.28 minus P of B intersection C is less than or equal to 1. Still values are there, simplification. So 0.17, 0.28. So 0.45, 0.75 is less than or equal to 1.5 minus 0.45 minus P of B intersection C is less than or equal to 1. So still we will calculate. So 1.5, 0.45. So 0.75 less than or equal to. So here I forgot to write 0. This one I already wrote now. Yes, yes, yes. 1.5 minus 0 means 1.05 E minus P of B intersection C is less than or equal to 1. After that, subtract for every term 1.05. Here I want to write it. So 0.75 minus 1.05 is less than or equal to 1.05 minus P of B intersection C minus 1.05 is less than or equal to 1 minus 1.05. We are subtracting. Yeah, dear students, here after this value, here we need to change it. Why? Because we did not write correctly the terms. Otherwise, we will make it like this. 0.3, 0.4, 0.8. First, we have to add these values and including these values. So you will get it as this is 1.2 and so like this. First we have to add, that is 0.3, 0.4, 0.8. So 1.5. These three values are 1.5. Next, including 0.09 also if you add, so 1.59, including 0.09. So the rest of the terms 0.28 and 0.08. So it will become 0.36 minus 0.36 minus P of B intersection C. So that's what I forgot in the last step. So that is the reason. These two we are adding. So now one by one we will do it. 1.59, 0.36 if you subtract. So 1.23 here. 1.23 minus P of B intersection C is less than or equal to 1. So how much we have to subtract on both sides? 1.23 we can subtract in every term. So 0.73, here I will write it. So here 1.23 minus this value is there, no? So we can subtract 0.75 minus 1.23. 1.23 minus P of B intersection C minus 1.23 is less than or equal to 1 minus 1.23. I hope you people understand, dear students. 0.75 minus 1.23. If you subtract from here, you will get roughly 1.23, 0.75. So 8. So 0.48. That also minus 0.48. This side we are getting minus less than or equal to. So minus 1.23 plus 1.23 will be cancelled here. Minus P of B intersection C less than or equal to 1 minus 1.23. So minus 0.23. I hope you people understand, dear students. If you remove minus from 0.23 to 0.48, you can write it. We are removing the minus. So 0.23 is less than or equal to P of B intersection C is less than or equal to 0.48. We know that alpha is less than or equal to x is less than or equal to beta, implies that we can write x belongs to closed interval of alpha comma beta. Similarly, that implies that P of B intersection C belongs to closed interval of 0 comma 23 comma 0 comma 48. Hence proved. They are asking to prove this result now. Yeah, here only be careful, students. So I am adding these values perfectly. First thing is that this is the standard result. P of A union B union C. Any probability sample space is always equal to 1 or less than 1. So less than or equal to 1. After that, given P of A union B union C is greater or equal to 0.5. From this, 0.75 is less than or equal to P of A union B union C. From 1 and 2, we are writing. This value we are writing as by using addition theorem on probability for the 3 events. After that, simplification. We'll move on to the next question. The next question, yes please. The probabilities of 3 mutually exclusive events are respectively given as 1 plus 3p by 3, 1 minus p by 4, 1 minus 2p by 2. Prove that 1 by 3 is less than or equal to p is less than or equal to 1 by 2. So how to prove this value? All are probabilities of 3 mutually exclusive events only, no? So one event I am assuming that E1, comma E2, comma E3 are mutually exclusive events. Whenever they are mutually exclusive event, their disjoint is 0, probability of disjoint. Then we have P of E1 union E2 union E3 can be written as P of E1 plus P of E2 plus P of E3. Sir, why can't write minus P of E1 intersection E2 minus P of E2 intersection E3 minus P of E3 intersection E1 plus P of E1 intersection E2 intersection E3? Whenever they are mutually exclusive events, the disjoint of E1 E2, E2 E3, E3 E1, E1 E2 E3 all are goes to be 0. That is the reason we are writing like this. And also we know that E1 probability is this one, E2 probability is this one, E3 probability is this one. P of E1 is equal to 1 plus 3p divided by 3. We know that the probability is lies between 0 and 1. So that implies that 0 is less than or equal to p of e is less than or equal to p of 1. E of e1. 0 is less than or equal to any probability lies between 0 and 1. It should not be more than 1. And it should not be less than 0. So this is the probability of. What is p of e1? This is the minimum value, this is the maximum value. So this question we are going to prove maximum and minimum values. So 0 is less than or equal to p of e1. 1 plus 3p divided by 3 is less than or equal to 1. So I want to cancel the denominator 3. So multiplying all the terms by 3. 0 is less than or equal to 1 plus 3p is less than or equal to 3. But I want only p here. So here 1 is there, no? So subtract 1 for every term for this inequality. 1 plus 3p minus 1 is less than or equal to 3 minus 1. So minus 1 is less than or equal to 3p is less than or equal to 2. But I want only probability here. P value. So dividing on both sides by 3. P multiple is 3 now. Minus 1 by 3 is less than or equal to p is less than or equal to 2 by 3. You put one equation number 1. Similarly, you take for the second probability p of e2. Similar way you can do that. I am doing here. P of e2 is equal to 1 minus p divided by 4. So probability is lies between 0 and 1 only, no? Like this you write it. That implies 0 is less than or equal to p of e2 is less than or equal to 1. So 0 is less than or equal to 1 minus p by 4 is less than or equal to 1. So in the denominator I don't want to see that 4 value. So throughout multiplying by 4 inequality, 0 is less than or equal to 1 minus p is less than or equal to 4. Here I want p value. So here 1 minus p is there, no? So to get 1 here, to get only p, subtract 1 from each inequality here. 0 minus 1 is less than or equal to 1 minus p minus 1 is less than or equal to 4 minus 1. That implies that minus 1 is less than or equal to minus p is less than or equal to 3. Minus 1 is less than or equal to minus p. If you remove minus here, write the reverse here. Whenever you are multiplying by minus, inequality will change. 1 is greater than or equal to p is greater than or equal to minus 3. Whenever you are multiplying by minus, which every term of this inequality will change. So after that we can write as minus 3 is less than or equal to p is less than or equal to 1 only, no? So keep that. Equation number 2. Similarly, third one you take. P of E3. What is P of E3? 1 minus 2p divided by 2. So that implies that P of E2, 0 is less than or equal to P of E2 is less than or equal to 1. That implies 0 is less than or equal to 1 minus 2p divided by 2 is less than or equal to 1. So multiplying by 2 on both sides. 0 is less than or equal to 1 minus 2p is less than or equal to 2. After that, here I don't want to get 1. So subtracting 1. 0 minus 1 is less than or equal to 1 minus 2p minus 1 is less than or equal to 2 minus 1. So that implies that minus 1 is less than or equal to minus 2p is less than or equal to 1. But I want here, from here, if you multiply by minus, inequality will change, na? I already said that. 1 is greater than or equal to 2p is greater than or equal to minus 1. So if you write reverse, minus 1 is less than or equal to 2p is less than or equal to 1. But we want p value from here. So 2p is there. I want p value. So dividing on both sides by 2. On not both sides in every term. Minus 1 by 2 is less than or equal to p is less than or equal to 1 by 2. Put that equation above 3. We'll conclude after rubbing the board, and these values are right at one place. Yeah, these are the 1, 2, 3 equations we got it in the previous step. Now, again you have to consider, this is also one of the probability, E1, E2, E3 are mutually exclusive, then we have probability of E1 union E2 union E3 equal to P of E1 plus P of E2 plus P of E3. Because the rest of the terms goes to be 0 since the mutually exclusive events. 0 is less than or equal to P of E1 union P of E2 union P of E3. Sorry, E1 union E2 union E3 is less than or equal to 1. This value is equal to what? 0 is less than or equal to P of E1 plus P of E2 plus P of E3 is less than or equal to 1. So substitute these values. This is P of E1, P of E2, P of E3. 1 plus 3p by 3 plus 1 minus p by 4 plus 1 minus 2p divided by 2 is less than or equal to 1. 0 is less than or equal to, here LCM is 3, 4, 2. What is the LCM? 2, 4, 3, na? 12. So 12 is the LCM. 4 plus 12p plus 3 minus 3p, 6 minus 12p is less than or equal to 1. Plus 12p minus 12p get cancelled. And all multiplying by 12. So it will become 0 is less than or equal to 4 plus 3, 7, 7 plus 6. 13 minus 3p is less than or equal to 12. So subtract 13 from every term. So 0 minus 13 is less than or equal to 13 minus 3p is less than or equal to 12 minus 13. So from here minus 13 is less than or equal to, so here I forgot to write, I told but I did not write. These two will be cancelled. Minus 3p is less than or equal to 12 minus 13 is minus 1. But we want only one probability only. So p, to get the p, before that, if you eliminate minus, inequality will change. So 13 is greater than or equal to 3p is greater than or equal to 1. That you write as a reverse. 1 is less than or equal to 3p is less than or equal to 13. So here minus 1 by 13. 13, yes. Dividing by 13. Sorry, dividing by 3. 1 by 3 is less than or equal to p is less than or equal to 13 by 3. So here 4 plus 3, 7, 7 plus 6, 12. Is there any pending value here? 4 plus 4 3s are right. 3 minus 3p. 2, 6, 6 minus 12p. Yes, correct on. So equal to 12. So this is also one of the value. Equation number 4. After getting these 4 equations, dear students, you observe that these are all minimum values, these are all maximum values. This is minimum, this is maximum. So among these minimum values, we will get a minimum value. Among these, maximum values will come. So we can get that this inequal, the probability is lies between, we will get it from here. So minimum values. What are the minimum values we have? Minus 1 by 3, minus 3, minus 1 by 2. minus 1 by 3, minus 3, minus 1 by 2 and 1 by 3. One minute. See here students, previously I wrote here minimum of now, so that is not correct one. Here, after getting up these 1, 2, 3, 4, from 1, 2, 3, 4, here we have to write conclusion from 1, 2, 3, 4. So first maximum of these side values, minus 1 by 3, minus 3, minus 1 by 2 and 1 by 3. What is that among these values, which one is maximum? All are negative, only positive is 1 by 3 only now. So P of 1 by 3, that is this probability. And like minimum of, reverse you take here, minimum of, to find the inequality, that means the probability P lies between 1 by 3 and 1 by 2. To prove this inequality, this will be hold when we are taking maximum of these values and minimum of these values. So minimum of 2 by 3, 1 by 2 and 13 by 3. So among these, which one is minimum? 2 by 3 is 0.6, 1 by 2 is 0.5, 13 by 3 means it is more than, so 3, 4 is 4 point something. So among that 1 by 2 is 0.5, this is 0.6 will come approximately, 0.5 something. So 1 by 2 is very less value, minimum of these values is equal to 1 by 2. So the probability lies between 1 by 3 and 1 by 2. So this inequality holds P means probability. P holds 1 by 3 is less than or equal to P is less than or equal to 1 by 2. So hence the result, they are asking to prove 1 by 3 is less than or equal to P is less than or equal to 1 by 2. This type of this important type question, dear students, and these type of questions they will ask in MSET also. I hope this question asked in the previous MSET also. This is the way you can go. We'll move on to the next question. Yeah, the next question, dear students. On a festival day, a man plans to visit 4 holy temples A, B, C, D in a random order. Find the probability that he visits. The first question, A before B. Second question, A before B and B before C. So this is a little logical question. We will do in the cases, dear students. So on a festival day, a man planned to visit 4 holy temples. Given 4 holy temples, A, B, C, D. 4 temples are there. So a man plans to visit 4 temples in how many ways? A man visit the 4 temples, in 4p4 ways, that is equal to 4 factorial ways. So the total number of possibilities n of s is equal to 4 factorial, that is equal to 24. I think everyone understand. 4 temples are there in 4 factorial ways. He wants to visit total number of possibilities, 4 temples. Now come to the first question. E1 be the event that the man visits the temples A before B. Event that the man, the person simply visits that. E1 be the event that Man visits the temple, which is the temple A before B. So n of E, what possibilities we are getting? N of E, E1 we are taking n of E1. So what possibilities we are getting? So total, observe dear students carefully. So 4 temples, these are all places. Come to the case 1. 4 temples are there, no ABCD. A before B. Suppose if we take A will be here, B we can accommodate either here or here or here. So 3 possibilities are there for the temple B. So out of these 3, one place can be accommodated in 3P1 ways. I am writing here the cases. 3P1 among that. Suppose B will be accommodated here, the rest of the 2 is there, no? So here C and D can be accommodated in 2P2 ways. The rest of the C and D. Or means what? Plus. Suppose the temple is here. A temple is in this case. A temple will be here. Before A before B should be there, no? So only 2 possibilities are there here. The B temple either here or here. So compulsory the B temple will be here. Among the 2 possibilities, in one place we can accommodate, it can be done in 2P1 ways. And here we can accommodate the rest of the temples in 2P2 ways. Or another possibility also we have. Suppose if we take here, B compulsory should be here. So only one possibility is there here. It can be done in 1P1 way. The remaining 2 places can be done in 2P2 ways. So what are the possibilities? These are all, or means we can add all these values. So n of E1 is equal to 3P1 is 3 into 2P2 is 2. So 3 into 2 6. R means plus 2P1 is 2 into 2P2 is NPN 1. So 2 into 1 is 2. Sorry, 2P2 is 2. 2 factorial. NPR. N factorial by n minus r factorial. So 2 minus 2 factorial is 2. 2 into 2 is 4. We can write as like this. Plus 2 into 1. 2. So 6 plus 4 plus 2 is 12 possibilities. Therefore, the probability of E1, P of E1 is equal to n of E1 by n of S. So n of E1 is 12. 12 by 24, that is equal to 1 by 2. I hope you people understand here. These are the possibilities will come. In the case of E1 be the event that man visits the temple A before B. The special case. A before B, these are the possibilities will come out. We'll go on to the second case. Can I explain there? If I come here, something you are not able to see properly. Why? Because my... Okay, we'll move it on. E2 be the event that E2 be the event that man visits the temple A before B and B before C. Here conditions are there, dear students. So here also we may arise the cases n of E2. What possibilities are getting? Once observe carefully. So like this, previously we draw a rough figure now. So 4 boxes you can draw. In this 2, AB we can take it. In the first case, suppose if we take A, B like this way, A before B only, no? This already done. A before B already we got the case. So remaining B before C means for C the possibilities are these two. So only it will be done in 2P1 ways, any one of the case. So here among the two places we can done in 2P1. The rest of the one place, two places are there in this one, we can accommodate the C. The rest D will be 1P1. Or suppose the situation is A, B compulsory should be there. Like this you can take before B, A before B it will be done in the possibility. And B before C. So C should be here. C should be here. It can be done in one place. D automatically will be here. So 1P1 into 1P1. Only one possibility is there for the C. B before C. Only C should be here. Then only it will be. C either here or here you can take. B before C. That is the reason 2P1 we are ready. But here compulsory only one possibility is there for this. 1C1. Here compulsory the remaining D will accommodate. Or this possibility compared with this. Another possibility is also there. What is that another possibility? If we take here A, B, C. So first conditions apply. A before B it was there. B before C is also there. So automatically D will be accommodated in this. So it can be done in only 1P1 way. D can be accommodated. A before B it should be there. And B before should be is also there. No need to do anything. Already accommodate. If you take like this way. If he visits in that way. So the remaining possibility here only one, that is D possibility, D table. So it can be done in 1P1. So N of T, how to write? N of E2 is equal to 2P1 means 2 into 1. So we can write as 2. Plus R means plus 1P1 into 1P1 is 1 plus 1P1 is 1. So total 4. So therefore the probability of the second event P of E2 is equal to N of E2 divided by N of S. So total possibilities already we wrote at 24. So N of E2 is equal to 4 divided by 24 equal to 1 by 6. I hope you people understand. These are the possibilities, dear students. We will move on to the next question. The next question, dear students. From the employees of a company, 5 persons are selected to present them in the managing committee of the company. The particulars of 5 persons are as follows. These are the 5 persons particulars. A person is selected at random from this group to act as a spokesperson. Find the probability that the spokesperson either a male or above 35 years. Here only we can understand that which formula or which theorem we can apply. The selecting person, the spokesperson, either a male, so A be the event of selecting the person is a male. A equal to the event of selecting a person is male. How many male persons are there here? 1, 2, 3. Harish, Rohan and Salim. So 3 persons are there. So N of A is equal to, from these 3 persons, 1 person can be selected in 3C1 ways, therefore 3. So either a male is over. The person, the spokesperson above 35 years. B the event of selecting a person whose age is above 35 years. 35 years above here and here. 35 above years. 46 and 51. So how many persons are there? Sheila and Salim. Here only person. They are not mentioning male or female. So Sheila and Salim. So two persons are there. N of B is equal to 2C1, which is equal to 2. I hope you people understand. N of A, N of B, we got it. N of A intersection B, how it will come? So A intersection B. That means the selecting a person, male, and whose age is above 35. Among these two, whose male is here, Sheila is female and Salim is male. So only one person is there, no, above 35. So only one person will be selected in 1C1 way, that is equal to 1. So only one person is there. N of A intersection B, the event of selecting a person who is male and above 35 years. So therefore N of A intersection B is equal to 1C1, that is equal to 1. Are you able to see? Yes, you are able to write. Neatly I'll write 1C1, so on. After getting of N of A, N of B, N of A intersection B, sample space is required, N of S. Total how many persons are there? Actually before only I have to discuss. So total number of persons, here on I am writing. Before, if you want to write, you can write. Total number of persons. Total number of persons equal to 5. So that is N of S is equal to 5. From that you can select one student, no? One person, 5C1. So N of S is equal to 5C1. Now, the probability of the spokesperson either a male or above 35. Therefore, the probability that the spokesperson either male or above 35 years is either or means P of A union B. P of A union B is equal to P of A plus P of B plus minus P of A intersection B. So P of A means N of A by N of S, N of B by N of S, minus N of A intersection B by N of S. So which is equal to N of A 3 by N of S 5, N of B 2 by 5 minus 1 by 5. So it will become 3 by 5 plus 2 by 5, 5 by 5 minus 1 by 5, that is equal to 1 minus 1 by 5, which is equal to 4 by 5. Therefore, the probability that the spokesperson either male or the person above 35 years is 4 by 5. Therefore, the conclusion step, P of A union B is equal to 4 by 5. I hope you people understand, dear students. We'll move on to the next one. The next question is a good question conceptually. We will see that. Out of 100 students, two sections of 40 and 60 are formed. If you and your friend are among 100 students, find the probability that you both enter the same section, you both enter the different section. You have to assume that E be the event of you and your friend, that means both enter into the same section. Then what is the probability? E complement is you both enter into the different section. See, first, how many students are there total? 100 students are there. Observe carefully, dear students. Logically we are doing. 100 students are there total. These 100 students can be divided into two sections. One section contains 40, another section contains 60. So, in calculations, suppose a round word is there now. How to arrange this round word? Total 4 words are there. We can arrange in 4 factorial and 2 are alike. We can arrange it as 2 factorial. So, these are the number of permutations. We can accommodate in that way. So, similarly, total 100 persons are there. So, n of S, how to write? S is the sample space of 100 students. It can be divided into two groups, first section and second section. So, n of S we can write like this. Total 100 students can be accommodated in 100 factorial ways. In that, two groups are alike. 40 groups can be written as, can be arranged in 40 factorial, and 60 60 students group can be arranged in 60 factorial. They are alike students. This section, 60 students section, 40 students section. I hope you people understand. This is n of S. So 100 can be divided into two groups. So 100 factorial by 40 factorial into 60 factorial. This is the n of S. Now E be the event. E be the event that you and your friend, that means both, you and your friend enter to the same section. So what is the possibility I am explaining here? So n of E is equal to what possibilities? Suppose you and your friend, that means you both enter into the first section. You two people are among 100. So suppose if you are entering into the 100 people, they will become 98 only. They enter into the first section. So whenever two students, you both will be enter into the first section, the total will become 100 minus 2, that is 98 factorial. Suppose if you are entering into the first section, this 40 will become 38 only. So 38 factorial into, we cannot disturb the second section as it is, you can write 60 factorial. This is one of the possibility. You both enter into the first section, or means plus. In the next step we will write it. Or means plus. Suppose if you are entering into the 60 student section, from 100 anyway you are among the 100, you are the two people. So 98 can be arranged in 98 factorial. 40 we cannot disturb. Why? Because 40 can be arranged in 40 factorial. You are in the second section now. This is first section possibility. This is second section possibility. If you are in second section both, so 60 also 2 you can reduce. It will become 58 factorial. I hope you people understand, dear students. So therefore, the probability P of E is equal to n of E by n of S. N of E by n of S. N of E 98 factorial by 38 factorial into 60 factorial by n of S. 100 factorial by 40 factorial into 60 factorial plus 98 factorial by 40 factorial into 58 factorial by, yes, so this one, 100 factorial by 40 factorial into 60 factorial. So we can simplify one by one. 98 factorial, keep it like this only, by 38 factorial into 60 factorial. 60 factorial, you can cancel it. The remaining 40 factorial by 100 factorial plus, this will become numerator now. So here also 98 factorial by, here 40 factorial, here only you can cancel it. 58 factorial into 60 factorial by 100 factorial. Here only simplification calculations are there, dear students. 98 factorial by 38 factorial. 40 factorial can be written as 40 into 39 into 38 factorial. 40 factorial can be n factorial can be n into n minus 1 into n minus 2 factorial. So here also this way we are doing. 100 factorial can be written as 100 into 99 into 98 factorial. So n factorial can be written as n into n minus 1 factorial. Similarly, according to our convenience, we will write it like this and so on. This is the way. What is the use of writing this one? 98 factorial will be cancelled, 38 factorial will be cancelled. Here 0 get cancelled. 2 2s are, 2 5s are. Next 3 13s, 3 33s. So 13 2s are 26 by 165. That I will write it in the next step. So here I will write it before only 2 into 13, 26 by 13 into 33 into 5, 165 plus we will solve here also 98 factorial by 58 factorial. 60 factorial can be written as in terms of 58. 60 into 59 into 58 factorial. 100 can be written as 100 into 99 into 98 factorial. So 98 factorial, 58 factorial cancel. 2 3s are, 2 5s are. 3 1s are, 3 33s. So 59 by 165. This is about P of E. So if you add these two, how much we are getting on? 9 6 15 8 85 by 165. 5 table. 5 17s. 5 3s are. Again 5 3s are. 17 by 85. 5 3s are 15. Again 5 3s are. So therefore the probability of both enter in the same section is, here I already wrote N of E. Probability of both enter the same section equal to 17 by 33. So P of E complement is equal to probability of both enter the different section. So P of E complement is equal to 1 minus P of E only. 1 minus 17 by 33. So 33 minus 17 by 33, that is equal to 16 by 33. So therefore the pupil which are entering into the different sections, the answer is 16 by 33. Enter into the same section, 17 by 33. I hope you people understand, dear students. I think all the questions completed from the textbook. Yeah, That means complete 9b exercise till here completed. Now we will move to the condition probability in the next video, dear students. Condition probability, and based on that examples, multiplication theorem and examples, like this way we will give it. Thank you for watching and your support. Those who are watching first time our channel, please do subscribe and watch previous videos, and I will give the description to join in my Telegram channel. In the Telegram channel, I will provide the notes, PDF, whichever I am giving here, that I will provide as a notes. Thank you for your support. Maths with Panindra signing off. Jai Hind.